Yes, dear students. In last class, we have discussed about motion in one dimension. And today, we will discuss about motion under gravity. Motion under or against gravity. Against gravity. Against gravity, under gravity. But see here. We know we have already derived this formula for uniformly accelerated motion. Uniformly accelerated means in 1 second, in each 1 second, there will be fixed increase in velocity will occur. In 1 second, in every 1 second, there will be fixed change in velocity. If increase, positive acceleration. If the fixed amount of velocity will decrease, keeps on decreasing in each intervals of time, that is negative acceleration. That is called retardation. In case of positive acceleration, we have derived this formula. V is equals to U plus AT. S is equal to UT plus half AT square. This is the formula that we have already derived. And what is the last formula? Yes, anybody? What is the last formula that we have derived? V square is equal to U square plus 2AS. But see, S is the distance moved by the body. S is the distance moved by the body. Now you see here. S is the distance moved by the body. A is the positive acceleration. That's why plus sign is there. It means we can say that U is the initial velocity and velocity of the body is increasing with time. Velocity of the body is increasing with time. Now you see here. If in case of motion under gravity, we can see that any body is falling vertically downward. Since the direction of force of gravity, since the direction of force of gravity is acting in the direction of motion, in the direction of initial velocity. If we are letting any body to fall down, the direction of velocity is in the direction of motion. Now you see here in this case, this equation will become V is equals to U minus, the acceleration produced if we are letting any body to fall down, that is during free fall. If we are leaving this cap, free fall, or any body, what is the initial velocity? 0. If I am leaving this body to free fall, after 1 second, if I will measure the value of this body, its value will be 9.8 meter per second. What is the change in velocity? After 1 second, its velocity increased by 9.8 meter per second. After next 1 second, that is at the end of 2 seconds, its velocity will be added up by 9.8. 9.8 plus 9.8. Beta see here. Simply I am explaining what. If we are leaving any body to free fall, this is called free fall. Beta, when we are leaving any body, it means its initial velocity is 0. To fall on the surface of Earth because of gravitational pull of Earth. Earth attract any body toward the surface of Earth. Now see here, because of the gravitational pull, in every 1 second, there will be fixed increase in velocity. That is 9.8 meter per second. So we can say that after 1 second, at 0 second, its initial velocity was 0. After 1 second, its velocity becomes 9.8. After again, further 1 second, its velocity will be 9.8 plus 9.8. That is 19.6 meter per second. At the end of 2 seconds. Now at the end of 3 seconds, its velocity will be 9.8 into 3. At the end of 4 seconds, its velocity will be 9.8 into 4. So what we can see that in every 1 second there is fixed increase. So that's why here plus sign is there, and that fixed increase in velocity is called acceleration due to gravity. The fixed amount of increase in velocity is called acceleration due to gravity. And the value of this g is 9.8 meters per second square. So first equation becomes v is equals to u plus gt. Similarly, but a second equation will be modified into s. So vertical distance moved is written as h. Ut plus half gt square. Like this. First ut plus half a. In place of a, you have to write only g. And the value of g is fixed, that is the acceleration due to gravity. And its value is 9.8 meters per second square. Now the third equation, final velocity is equals to initial velocity. What is final velocity? What is initial velocity? If the time is 0, it means as the motion begins at time 0, whatever be the velocity with which the body begins its motion, that is called initial velocity. And after time t, what is the velocity attained by the body? That is called final velocity. Small v, small u is the initial velocity, v is the final velocity. V square equal to u square plus 2gh. 2gh. Now, motion against gravity. If you throw any body in vertically upward direction, the gravitational pull of force of gravity is acting. Force of gravity is acting vertically downward. Initial velocity is upward. So the direction of initial velocity and acceleration. Why acceleration? Because of the force. As we are throwing any body in vertically upward direction, the velocity of the body goes on increasing or decreasing? Decreasing. When we are throwing any body in vertically upward direction, the velocity of the body goes on decreasing. Why? Because the force is acting against the direction of motion. Against the direction of motion. That's why the velocity of the body decreases, and such type of motion is called motion against gravity. And only the formula in that case will be modified to v is equals to u minus gt. First equation, only minus sign. Second equation, distance, that is vertical height. Vertical distance is height, h equal to ut minus half gt square. And third equation modified to v square is equal to u square minus 2gh. This is the third equation. Now let us solve some question based on motion under gravity and motion against gravity. One question here. The building of height 980 meter. 1960 meter. With what velocity? A man should throw a ball in vertically upward direction so that the ball will reach to the maximum height. So that the ball may reach to the maximum height. What is the velocity which the ball should throw? So that the ball may reach. Ball may reach maximum height. Maximum height. So let us see here. We have to throw the ball in vertically upward direction. So this is the case of motion against gravity. Three formula here we have data. What is the question here? With what velocity the ball should be thrown in vertically upward direction so that the ball may reach to the maximum height. Height is given. So we can apply third equation. V square is equal to u square minus 2gh. What is the final velocity? You have to calculate it, initial velocity. Final velocity. What is the question? Ball may reach मैक्सिमम हाइट। बेटा यहां तक पहुंच सके, पहुंचने के बाद रुक जाए भाई, क्योंकि बोला गया है व्हाट शुड बी द मिनिमम। बेटा क्योंकि और अगर कोई भी वेलोसिटी तो इससे ज्यादा भी जा सकता है। व्हाट शुड बी द मिनिमम वेलोसिटी, मिनिमम मींस बेटा कम से कम यहां तक पहुंच जाए, रुक जाए भैया। तो इसीलिए केस क्या देगा, मिनिमम वेलोसिटी के केस में जीरो हो जाएगा फाइनल वेलोसिटी आफ्टर रीचिंग हियर। minus 2g, g is 9.8 and what is the height? 1960. But I u this side, u square is equal to this side, come this side, 2 into 19.6 into 1960. U is equals to root under 19 into 1960 meter per second. This is the velocity with which the ball should throw. Now, if you are asked that if someone is throwing this ball in vertically downward direction with velocity from the top of the building, from the top of the multi-story building, what is the height? Height is given. If a ball is thrown vertically downward with initial velocity of 19.6 meter per second, with what velocity it will collide and how much time it will take? Yes, beta. How much time it will take and with what velocity it will collide with the earth surface? Yes, anybody? Yes, beta, anybody? Can you tell me which formula will apply? With what velocity this ball will hit the earth surface? With what velocity? With what velocity the ball will hit the earth surface? Will hit the earth surface, and also find the time taken to hit the earth surface. Hit the earth surface. Let us see here. If you are asked to determine the time, what is the time taken by the ball to reach here, you can easily apply second formula, s is equal to or h is equal to ut plus half gt square. Let us see here. What is the height of the building? 1960 meter. What is the velocity, initial velocity with which the ball is thrown vertically downward? It is 19.6. And t is 4 times plus half g. G is 9.8 into t square. But see here, this is the quadratic equation. This is 4.9 t square, and this becomes 19.60. This comes this side, minus 1960 is equal to 0. Now by using quadratic equation, you can find the value of p. What is the value? 4.9 t square plus 19.6 minus 1960. Now by using quadratic formula, we can determine the time. If we have determined the time with what velocity the ball will hit, we can easily determine. But there is another way by which we can derive the formula. Let we have derived this formula. Now, final velocity for determine the velocity with which the ball will hit the earth surface. Which formula will apply? Third equation. G square is equal to u square plus 2g h. First equation also we can use. V is equals to u plus gt. Beta u is given 19.6. What is j? 9.8. And what is time? From here we have, when we'll find out this one, we'll put the value of time, we'll get the final velocity with which the ball will hit the earth surface. Now, through this formula we can also solve. This is the final velocity. What is the initial velocity? 19.6. 19.6 square plus 2 into 9.8 into what is the height of the building? 1960 meter. V square. So V is equals to root under this whole value. You will put this value here. Solve it, determine the root, that then you will get the final value of the given final velocity with which it will hit the Earth's surface. Let us see here. Now I'm discussing about most distance traveled by the body during nth second. What is our next topic? Distance moved by the body, distance moved during nth second. Nth second. Beta, what do you mean by nth second? Beta, see, for example, when we are dropping any body to fall vertically downward, what is the time? Time is 0 seconds. What is the initial velocity? U is 0. Now, after 1 second, time is 0. After 1 second, when time becomes 1 second, what is the distance moved? Ut plus half gt square. You can utilize this formula to determine the distance moved by the body during 1 second. What is the initial velocity? Since we are dropping the body, now see here, beta, after 1 second, what is the distance moved by the body during this first time? First second. What is first second, beta? पहला hours. During first second. जिससे पहले hour की बात करते हैं, बेटा घड़ी 0 पर चली जाती है 12 पर, और 12 से 1 बजे तक के बीच का जो समय रहता है, ये पहला आवर्स कहलाता है. So 0 to 1. 0 to 1. Now, so this is first hour, बेटा. बेटा 1 से 2 बजे तक के बीच का जो समय होगा वो सेकेंड आवर कहलाएगा. The time interval between 1 to 2 is called second hour. उसी तरह similarly, between 0 to 1 second is called the first second. Between first to second, this distance, this time interval is called second second. दूसरा second. Between second to third second, this time interval is called third second. Similarly, बेटा इसको 2 से third second, 2 से third second तक के बीच का टाइम इंटरवल, 2 to 3 सेकंड के बीच का टाइम इंटरवल को थर्ड सेकंड कहते हैं. सिमिलरली n-1 से n सेकंड के बीच के टाइम इंटरवल को n सेकंड, दिस टाइम इंटरवल इज कॉल्ड n सेकंड, इज कॉल्ड n सेकंड. So what is this time? N second means this time interval is called n-1 to n. What is this time interval? But this time interval during nth second. During nth second, what is the time interval? This time interval is n-1 to n second. This time interval is only 1 second, but we call this time interval as n-1 to n second. Now you see here, we already know the formula for uniformly accelerated motion. We will derive the formula distance moved during nth second during uniformly accelerated motion. During uniformly accelerated motion. Let us see here. We have already derived this formula. V is equals to dx upon dt. We know this formula. And V is equals to u plus at is equals to dx by dt. Now dt goes this side. dx is equals to, बेटा ये dt दोनों से प्रोडक्ट होगा, u into dt plus a t into dt. What is our aim? To determine the distance moved by the during nth second. So we, by taking proper limit, integrating above equation, because we have to determine the distance moved. This is the differential distance. This is what? differential distance. So integration means what, beta? Why we are integrating this equation? This is the differential distance moved by the body during time interval only due dt. बेटा हमें तो टोटल सम अप निकालना है बेटा, n-1 से n सेकंड में टोटल डिस्टेंस. What is the total distance moved by the body during this time interval? So we are integrating it to sum up to find the total change. So that's why what is the purpose of integration? To find the total change. What is the total change here? Displacement. So we are determining the total displacement moved by the body during nth second. So we will integrate this, integrating above equation. Integrating above equation by taking the limit of time. What is the limit of time? From what is the lower limit? Initial time is n-1 second to what is the final time? nth second. Now you see here, you integrate this. Let us see. Dx. We integrate this. U is constant velocity. What is the limit of integration? Beta n-1 to nth second plus at, a constant, p into dt. But see here, in this uniformly accelerated motion, u and a are constant. So we put constant always outside the integration formula. U means initial velocity and a is acceleration. We always take constant. That's why when we are integrating this equation, we put integration sign here. We are keeping out constant term outside the integration. बेटा outside the integration sign, outside the क्योंकि बेटा जो constant है वो तो fix है, तो we will not integrate. We will integrate variable terms time. What is the limit? n-1 to n second. Now see here, बेटा. Just I have explained in our previous classes how to integrate equation. The distance moved by the body during n-1 to n second is called Sn. This is the symbol of distance moved during nth second. And you will write u. What is the integration of dt? Beta t. Put limit n-1 to upper limit n plus a. What is the power 1? So power increases to n plus 1. Beta 1 है तो 2 हो जाएगा. Y power just comes down. Lower limit n-1, upper limit 1. Now how we'll solve this? See here. Beta see here. You put upper limit first. What is the upper limit? N minus. What is the lower limit? n-1. Close this. Plus 2 comes constant term. What is the upper limit? N square minus what is the lower limit? n-1 का whole square. U into n minus n. Bracket, when we open the bracket, it becomes this plus a by 2. What is the formula? And this is n square minus, write the formula for a plus b whole, a minus b whole is a square plus b square minus 2ab. This is the formula that we applied. Now open n minus n, 0 plus 1 remaining. U 1 into u remaining plus a by 2. Now you see here, beta, n square minus, when bracket we remove bracket sign, all the signs get changes because here is a minus sign. So this is n square plus minus 1 minus plus 2n. So n square minus n square, it will be 0, 2n minus 1. So formula will be u plus a by 2 into 2n minus 1. This is the formula of distance traveled by a body during nth second. Now you see here, if I will ask you Find the ratio of this. This is the formula for distance traveled by the body during n second. Now, here is the question. Find the ratio of distance moved during free fall of a body under gravity on the surface of Earth during 5th second and 8th second. Distance moved during 5th second and distance moved during 8th second. What is the formula that you will apply? You will apply during free fall. Free fall means we are leaving the body. We are letting any body to free fall. So in this case, we are not going. That's why the initial velocity of the ball or any body will be what? Will be 0. So what will be the distance? Now see it. What is the distance moved during the body during 5th second? U will be always take U as 0 plus 8 under gravity, so 9.8 under gravity 9.8 by 2. Now what is n second? N is 5th. 2 into 5. 2 into 5 minus 1 divided by. Second case, distance moved during 8 seconds. What is the initial velocity? 0 plus A is 9.8 acceleration up until under gravity. Because the body is falling under gravity, the value of A will be equals to G. Now 2n. N is what? During 8 seconds minus 1. So it will be, this will be, now its answer will be 10 minus 1, 9. 16 minus 1, 16 minus 1, 15. Like this. 9 is to 15. 9 is to 15. This ratio of distance will be 9 is to 15. So in this way, we can determine the distance moved by the body during free fall. One thing you should know, that during free fall of any body, the ratio of distances moved by the body in consecutive time interval are 1 is to 3, is to 5, is to 7, is to 9, is to 11, is to 13, is to 15, is to 17, all odd multiples. This is the distance moved by the body during first second. This is the distance moved by the body during second second. दूसरे second में distance. This is the distance moved by the body during third second, first, second, third, fourth, fifth, 6, 7, 8. But see, such type of problems are generally asked in your NET examination. बेटा ये जो मेडिकल एंट्रेंस के क्वेश्चन होते हैं या आपको आईटी में तो नहीं पूछे जाते हैं, बट मेडिकल एंट्रेंस के एम्स या नीट लेवल के क्वेश्चन जो एग्जामिनेशन होते हैं उसमें ऐसे क्वेश्चन जनरली दे आर आस्किंग. And so you can easily, but if you are not remembering this formula, then this trick you should know. 1, 3, all the first, all write all the odd numbers. 1, 3, 5, 7, 9, 11, 13, 15, 17, like this, 19. So what is the distance moved by the body during 5th second? Ratio of distance, and this one ratio is 4.9. The value of this distance is 4.9 meter. Beta, if you calculate the distance moved during first second, you may apply this formula. S is equal to UT. T is 1 plus half G T square. What is distance moved during first second? U is 0. 0 into T1. 0. Half G is 9.8. And during first second, 1 का square beta 1, 9.8 by 2, 4.9 meter. So distance moved during first second is 4.9 meter. Beta इसका multiple कर देना. Now see here, what was the question here? To determine the ratio of distance. बेटा यहाँ मैंने 1 के comparable distance moved by the body क्या होगा 4.9. तो बेटा अगर second में distance का ratio नहीं, what is the actual distance? 4.9 into 3. During third second, what is the actual distance? 4.9 into 5. During fourth second, what is the distance? Like this. No, here only you are asked to determine the ratio of distances. So during 5th second and 9th second, 1, 2, 3, 4, 5, right? 9, 6, 7, 8, right? 15. 9 upon 15. This is the ratio of distances moved during 5th second and 8th second. You can write like this. Let us see here. In this way, beta, we will solve some more problem related to this topic in our next class.